Uh, that's new. I've never heard that one before. It's gonna scare people. I will hand it over to my check. If anyone's got any questions or anything like that, please get in touch, however, whenever afterwards or anything like that. But also, I will share the website link on chat as well with you. And another thing, if you have any questions, you can put them in the chat or save them for afterwards. We'll leave some time to have questions after the workshop. Thank you. Maciek, over to you.
Cool, thank you, Maddie. Great, so thank you so much for coming. Today we're going to talk about hacking and how does it actually work. So as a form of introduction, my name is Maciek. I work for Good Praxis, which is a digital co-op based in London. I've been interested in computer security for quite some time, in programming, coding, and electronics in general since I was a kid. So this topic is very interesting to me, and I thought I'll just share some of the sort of knowledge or experience that I may have had with you. But enough about me. Let's just get cracking with the topic itself. So a small disclaimer. So everything you learn here is for educational purposes only. So obviously, if you do find something interesting here and you want to experiment with it and play around with something, please don't do anything malicious. But I do encourage everyone to learn to see how things are made and how, you can break things as well and then remake them and stuff like that. But anyway, let's get cracking. So let's start with the main question, which is, what is hacking? So we can see some hacking in progress on our screen right now. I think in films and TV series, hacking is often sort of described or shown as, people frantically typing on a keyboard. If you look at the screen, there's loads of different windows popping up. But obviously that's a sort of film-esque sort of description and sort of visualization of hacking. But what does it actually, what is it actually? Like, what is hacking? And I was wondering if anyone wants to perhaps try defining hacking in their own words. Like, how would you define hacking? Is there anyone interested in giving it a go, maybe in your own words?
Making things do what the original designers never thought they would do.
Yeah, excellent. That's a really, really good definition. Yeah, I definitely agree with that one. Anyone else wants to give it a go? All right then. So let's see what the official definitions. Let's say what the Wikipedia definitions say about hacking. So first up, we have hacker. So a computer hacker is a computer expert who uses the technical knowledge to achieve a goal or overcome an obstacle with a computerized system by non-standard means. That's one definition. Then we also have a security hacker. So hang on, I just need to move this window across. So security hacker is someone who explores methods for breaching defenses and exploiting weaknesses in a computer system or network. And long-standing controversy surrounds the meaning of the term hacker. In this controversy, computer programmers reclaim the term hacker, arguing that it refers simply to someone with an advanced understanding of computers and computer networks, and that cracker is the more appropriate term for those who break into computers, whether criminals or computer security experts. So I'll talk about this distinction later on, and like who's a cracker and who's a hacker. But for the time being, we'll just talk about everything as hacking in general. So you have these two definitions, but since this is my workshop, I'll present my own definition, because why not? So in my own words, hacking is a process of making software, hardware, or social interactions work in a way different from what was originally intended. So very aligned with what Billy said about like making things work differently and not in ways that weren't intended. And obviously, sometimes hacking is used for malicious purposes in order to access systems or information which is not publicly available. And then finally, most of the time, hacking involves exploiting human mistakes and oversights in code or hardware. So I think this is actually key, because I think a lot of times when people think about hacking and again, watching films and TV series, sometimes you imagine it as, say someone's breaking into your home and a hacker would like use a massive hammer or like some super technology to like cut a hole in your window and break in. But actually the reality is that a hacker would just notice that your window's open and they'll just like squeeze through the window into your house and then rob you. That's basically how it works. Like it's not really like, using like hacker system 2000 and then hacking a computer. It's actually just finding mistakes that were made or oversights and then seeing how you can use them to your advantage. Right, so now that we have the main definition out of the way, let's talk a bit about terminology so that it's easier to understand what I'm talking about. So I assume that everyone here has at least some sort of basic understanding of like technical terms. So I assume you know what a byte is, a kilobyte or a server, but I will try to go through some terms here just so, you know, there's no confusion about like what we're talking about. So first up, we have an exploit. So an exploit is just like general term for an attack or like a bug that's being exploited. So for instance, if there's a mistake and a hacker exploits it, they are using an exploit, which is basically a method or a piece of data or anything that they use in order to achieve the goal of breaking into a system or making something work differently. Next up, we have black, gray, and white hats. I don't know if you've ever heard about black hat hackers and white hat hackers. These are not hackers with different fashion senses. Black hat hackers usually are hackers who use their skill or their knowledge for malicious purposes. Then white hat hackers is usually a term reserved for people who are computer specialists who will try to hack into systems, but actually they're doing it in order to, usually they're doing it for their own employer, trying to see, do what we call penetration testing, which is to see if it's actually possible to break in an existing system. And obviously they do it in a very transparent manner. So they're not doing it in a malicious way, they're actually doing it to improve security of a specific system. And in between, we have gray hat hackers. So these are people who usually like experiment with different things. They might break into a system just to see if it's possible. They might then send an email to that company saying like, oh, I've discovered this hole. But like basically they are like in between the sort of malicious kind and the sort of like more transparent kind, so to speak. Next up, we have a term, which is a bit derogatory, but script kiddie or skid. So that's a term often used by hackers. And what we call script kiddies is people who find an exploit online or find a solution online, how to do something, how to hack something, and then they try to use it without actually understanding how it works. So the reason we say script kiddies is because often actually in the past, there were situations where banks or major websites were hacked by teenagers who simply found an exploit online. They didn't really understand how it works and they were just sort of playing around with it and broke a major website or even like broke into a bank just using those scripts that they found online. So hackers refer basically use the term script kiddies to people who are inexperienced and then basically they, I guess, are not aware of the power or not aware of the consequences that something may achieve. But also like because a lot of times obviously teenagers who might break the law will not face consequences as serious as adults who do the same. So yeah, basically it's people who want to be cool as soon as possible, find something quick, use it, and then there we go, the hackers. Amazing. And then finally we have a 0-day. So a 0-day exploit is basically an exploit that is not known to anyone or to the security community so far. So the reason it's called 0-day is because it's been 0 days since the exploit has been discovered. What that means is that if people use 0 days, it means that no one is aware that there's an exploit, no one is aware that there's a problem with the system, and often these kind of attacks and these kind of exploits are sort of traded on like black markets and between hackers just because how easy it is to deploy them because nothing has been done yet to prevent them from working. And so that's why they're called 0-day exploits. Excellent. Okay, so now that we have all these terms out of the way, what I would like to talk about is different types of attacks that are there. So I'm going to explain how they work, why they work, and how hackers or programmers use those to basically break a system and exploit them. Right, so first up, we're going to talk about buffer overflow. So the official definition of a buffer overflow is an anomaly where a program, while writing data to a buffer is just a piece of memory, overruns the buffer's boundary and overwrites adjacent memory locations. This might sound a bit complicated, but I'll try to explain it in a sort of more understanding manner. So I hope you all sort of understand the concept of memory, right? So you have a computer, you store data in memory. This is just like a location where a computer can send data information and just store it there for later use. So imagine we have a piece of data or like a data structure, like the one we see on the screen. And imagine you have a piece of software that stores a name of a user and then the number of credits they have. And let's say they can spend those credits on different things. So in this case, a developer, a programmer, assumed that they will need probably around, 8 bytes to store a name and about 4 bytes to store the number of credits, right? So they assume that whenever they get a name, they can just put it in this container where they allocated 8 bytes for it. And then whenever they need to update the credits, they'll store it over there on the right-hand side if they ever need to update that number. And the reason why programmers allocate memory beforehand is just because it's easier to access, right? Because you always know where to look for a name, where to look for another number of credits, and that sort of size, when it's fixed and certain, it's just easy to operate with. So, you know, if you write a piece of software like that, easy peasy, just read the name, put it into memory, that's fine. So for instance, imagine if I'm called Alice and I type in Alice, then I have ALICE in my memory. If I'm called Bob, then it'll be BOB in memory, everything's fine. However, if the programmer hasn't considered specific scenarios, like for instance, the fact that perhaps the name could be longer or someone will try to put a longer name, what can happen there? Well, imagine someone like a malicious person, instead of putting the real name or like a short name, they put Kate 999999999, and it just sort of grows like that. So what happens now is the buffer has been overflown, like it overflowed. So the information from the name is now leaking into, overflowing into the memory location where we have the number of credits. So you see what happened here, right? I put my name, but actually by putting my name in, I've changed the number of credits that I have. So I originally had 20 credits, now I have 9,920 credits. The reason this worked is because a programmer didn't check how long is the name that I'm putting in. All they did was like, please give me your name. Okay, great. I'm grabbing it. I'm going to put it in memory and I don't care how long it is. So that's a mistake that someone made in code. And it's actually a mistake that often happens and it's very often exploited. So in this scenario, I've managed, just by entering my name, I've managed to hack the program and actually change the value of credits that I have just by doing that. Obviously, this is a very simple example and it's a lot more complicated in like real world environments. However, it just shows you like how overflowing a buffer and actually exploiting someone's mistake, because this is a mistake that someone made, an oversight, can actually allow you to achieve like something that wasn't intended to. Does that make sense so far? Yeah, is it all good? Wicked. All right then. Cool. So moving on, we have the opposite of a buffer overflow, which is a buffer overread. So that's an anomaly, where a program, while reading data from a buffer, overruns the buffer's boundary and reads or tries to read adjacent memory. Right, so opposite of the previous problem, basically the program reads a bit too much memory than it was supposed to, and that achieves like a different sort of effect than what was intended. So actually in 2014, there was a quite famous hack or exploit that was discovered. I don't know if you've ever heard of it, but it was called Heartbleed. And this attack, which was used actually by some hackers, affected something that we call OpenSSL, which is implementation of a security protocol. It doesn't really matter exactly what it is, but basically it exploited something that's used across many different computers. And what it did was it abused a process that we call a heartbeat, which is a way to check if a server, a computer, is running and fully functional. And it was a simple bug, but the consequences were huge, with millions of servers affected. So I'm going to explain actually how this exploit works to you, and you will see how a real life example of an exploit was used what was it, 7 years ago. Right, so let me explain to you how Heartbeat works. So Heartbeat is a simple process. I send the server some data, usually a text message, and then provide its length and size. I then ask the server to send it back to me, right? So I say like, here's the word potato, please send it back to me, right? And I'll say like, here's the word potato, it's got 6 characters, can you please send it back to me? If I hear potato back, it means great, I can, the server's running and everything's fine. So can anyone guess what went wrong? Like, can anyone guess where the problem is or what was the oversight? Has anyone got any ideas about this? No?
I can see how you could misuse that in terms of trying to test how the internal behavior of the program was running.
Yeah.
So it would, someone who was trying to understand the system could use that sort of iterated process, use an iterated process to trace exactly what length of the what length of data stream would be that the program would accept, and use that as a way of understanding the internal operations. At which point you're then able to directly get access the program in a way that it wasn't originally designed to be used.
Yeah, excellent. That's a really good answer. So basically what happened was the programmer who wrote this piece of code forgot to check how long actually is the words that you sent, right? So this is something that actually happened in real life, and this is not just like like showing you like a theoretical example. This is actually the problem that existed for like quite some time. So imagine I'm sending you the word pumpkin, which is 7 characters long, and I just say like, please send it back to me. So the server sends pumpkin back. But what if I say, I am sending you the word pumpkin, which is 128 characters long, send it back to me. So now the server, it's just a server, it's silly. It'll be like, okay, here's the word pumpkin. But since I told the computer the word pumpkin is 128 characters long, even though that's not true, that's just made up, but the computer didn't know, it just keeps telling you like things that it has in its mind, right? So it'll be like, it could be admin passwords, it could be some additional data that was in memory. It will just keep telling you yeah, if it's like pumpkin, it'll be like PUMPKN, then it's just like, imagine you don't stop talking, you just start saying everything you have in your mind, like it's just like a stream of consciousness. This is actually how it worked. So instead of just not trusting what the user is saying, you should instead just calculate the length of the string yourself, or the piece of data that you send, instead of trusting the user that they tell you exactly what is true and what isn't. So it's a huge oversight, and luckily it was fixed. And there was this whole controversy, how did it happen, and then was it done on purpose and stuff like that. But trust me, mistakes like these happen a lot. And I know they sound silly, I know they sound simple, but programmers, developers are not perfect human beings. So even things like that can often happen. Whoops, right. So we have 2 examples now affecting memory. So what I'm going to talk about now is a different type of attack, which is a denial of service attack, a DOS attack. I think a lot of people may have heard about this before, because it's often talked about when sites are not available, and a lot of people say, oh, they were DOSed, or there's been a denial of service attack used against them. So denial of service attacks cause a service to get overloaded with requests, causing it to stop being available or functional. So what does that mean? So let's look at this little example over here. So let's say we have a help desk, and you can call that help desk and you get some information. And we have a team of 3 people. We have Robbie and Robert on the team. Robert is a new member of the team. He previously was modeling for some stock footage, and now he's just liking to speak to people on the phone. So imagine you have 3 people, right? And then you know how it works, right? People phone in. Let's say there's 3 people talking at the same time. Then obviously all 3 employees are busy answering those calls. Then you form an orderly queue, and then hopefully, if it's not too busy, then you're next in queue, and then you can be served by Rob, and you can get some answers for your questions from him. So this is like a healthy system, right? This is a healthy system where the queue is not too long. The number of Robs is good. Like you can handle a lot of calls. Everything's perfect. Everything's fine. But what happens if there's too many people, right? So imagine now we have a situation where there's normal human callers, but actually robots start calling the helpline as well, right? And they call the helpline and they just like start talking like about weird stuff, asking weird questions and stuff like that. And obviously Rob doesn't know if it's a robot or not. They'll just start answering and trying to help them. But what happens is that, you know, real people can't actually access the helpline anymore, right? They're waiting in line, they're waiting, like wondering what's going on, and the robot's taking their time, asking about, you know, mathematical questions and stuff like that. Rob is trying his best to answer all of them. And it's like, you know, just takes a while to answer all these questions. So this is what is a DOS attack, essentially. So if you have a website and suddenly you get loads of traffic sent at that website, obviously the server can only handle, you know, an X number of requests. And once there's too many, they get queued up, and basically a website is just basically knocked off online, right? So you can't access a website anymore. So actually, in theory, this is a simple attack, right? If you have enough resources, you can just like spam a server and it will stop responding to people. So often you'll hear stories like, oh, hackers took the FBI's website down and stuff like that. But actually, the thing is, to hackers, usually this is like someone saying, someone took down a poster that FBI posted on a wall. Like it's a simple thing to do. It's just like easy to overload a service if you know what the capacity is and how much you need to generate. So there's another term which is related, which is a DDoS. So a DDoS is a distributed denial of service attack. So for instance, in this scenario, say Rob wants to calls his boss and says, like, we have this situation, robots are calling us, we can't tell who's who. But the boss is like, oh, but aren't they calling from the same number? And like, oh yeah, they're calling from the same number. Okay, that makes sense. So all we have to do is block that one number, right? And we block that one number, the robot's number, great, we're fine, right? So obviously hackers have a way around it, which is a distributed denial of service attack, which actually means that all the numbers are different. So every time the robot is calling, it's got a different voice, it's got a different location, it's got a different phone number that's been calling. And that way you can never tell, are you speaking with a real person? Are you speaking with a genuine human being, or is it a robot again? Likewise, when you have a website and you use a distributed denial of service attack, those requests will come from many different countries. They'll come from Asia, America, Africa, so many different countries. And obviously there's no way of distinguishing, is this a real request? Is it a human requesting it, or is it a robot? Is it a spam bot? You can't tell. That's why they are very powerful, those attacks. In order to achieve them, that's a different story. You have to have like infect like a whole network of computers. You know, you can buy server space and try to do that. There's many different ways of achieving it, but obviously when a situation like this happens, it's just impossible to deal with because you just have no idea how to distinguish a robot from a human being. That's why these attacks can be so painful and so damaging to servers. Right, okay. So are there any questions so far about what I've been talking? Everything okay? Cool, okay. Oh, Maddie, is there a question?
No, I was just going to say this is great. Thank you. I find it really interesting because I don't know much about hacking, but I like how you've made it really simple to understand.
Excellent, thank you, Maddie. Great, so moving on. A DOS attack can also be sometimes combined or be a result of a brute force attack. So a brute force attack is when you try different combinations of data until you reach a desired result, right? So imagine I don't know, I have a friend who annoys me and I want to hack into his Facebook account and post like a picture of a sausage and laugh at him or something like that. I don't know. So imagine I know his email address and I try to log into his account. So I'll first of all try one password, and then I'll try another one, and I'll try another one, and I'll try another one until I am able to log in. So that's essentially a brute force attack. But normally a hacker wouldn't use just type in many different combinations. They might write a piece of software that will do it automatically for them. So we'll keep trying different combinations until it cracks the password. So it might start with one password and try another and try another. And if it's a computer and the server is not set up correctly, they might be even able to try like 1,000 combinations a second and just like keep trying. And that is a brute force attack. And often that can actually result in a denial of service attack, because by just asking for the password and just by trying a different password, you can overwhelm the server, and that can actually achieve the sort of like result of actually the server going down as well. So this is, for instance, one of the reasons why it is recommended to have a long password, because actually for a computer, say your password is just 5 characters long, it doesn't take too long for a computer to try all possible combinations of 5 characters, basically. So that's why it's often required to have like at least 8 or 12 or 16 characters, because at some point it's completely impossible mathematically to crack a password, because there's so many combinations, it would take you the length of the universe to try all of them. If it's short, then actually is quite possible for people to just try all these combinations. Right, so this is why actually often you are asked on websites, are you a robot? And you have to take this thing and you have to answer some questions, because that's how they can actually check if you are a robot or not, by just genuinely trying to answer the question. Obviously you can try to sort of, you know, exploit it in some certain ways and pretend that you're not. But yeah, this is actually one of the reasons why we see that little widget, and people will try to sort of check if we're a real human being or not just a piece of software running on a website. Right, so moving on to a different type of attacks. This sort of category is called code injection attacks. So it's a popular attack which uses a bug or oversight to inject code, which then gets executed by the target machine. Probably the most common one is an SQL or SQL injection. Right, so what do I mean by code injection attacks? So you know this like silly joke, right? When you can call someone, like say you call the train station or like a bar and you say like in Simpsons, like, yes, I'm looking for a friend of mine. Hold on, I'll check. Last name Jas, first name Hugh. Hold on, I'll check. Hugh Jas, somebody check. I'm looking for a Hugh Jas, and everyone laughs. It's so funny, right? So basically you've made the bartender say something silly that wasn't intended, right? Just by injecting the words, you've made him say a silly sentence, right? Silly joke, but it actually explains how code injections work. So let's talk about one type of these injection attacks, which is called a SQL injection. So I'll just first talk about what SQL is, or SQL, depending on your pronunciation preference. So SQL is a language used by servers to communicate with the databases, right? So imagine you have a website, and the website has a server. And the server has all the data, like users, profiles, articles, and stuff like that. So whenever you want to read an article, the web server might then try to communicate with the database and say like, hey, database, could you send me this article which has ID 123? And the database is like, cool, here you are. And then the web server displays it to you, right? So often, you know, you actually need a way of communicating with the server. So that's why SQL and similar languages were invented. So you can actually speak to them in a specific way and then get the data back that you need. Does that make sense? So for instance, say if I, you know, I want to say, give me the profile image of the user who uses Theo123 as the username. And then the database will know exactly what to look, gives me that data, everyone's happy, right? Cool. So let's look at an example here. So imagine you have a website, and on this website, you can provide a film ID, right? Let's imagine it's a film database, right? And you're like a film specialist and you know film IDs and you can enter them. And the purpose of the website is that you enter the ID, you click show film, and then the website shows the film that matches that ID, right? So imagine I put 95761, and then the web server will have to ask the database for that film, right? Because it doesn't know about the film, it can't store data on its own, it needs like a big database to store information, right? So it will say, select title from films where ID equals 95761. So this is actually an SQL statement, right? It makes sense, right? So I'm asking the database, could you give me the title of the film which has ID equal 95761, right? Does that make sense, right? Just a way of requesting data, right? Cool. But what happens if I actually do not enter a film ID, but actually enter something else as well? So this time around, I've entered 95761 and some text as well. So what happens now is I tell the database, hey, can you give me this film? Its ID is 95761. And by the way, could you actually delete all the films from the database? And the server will be like, okay, fine, I'll do it, because they trust the web server. And this is because again, a mistake on the programmer's side. They haven't checked what sort of information the user is providing. So you remember with Heartbleed, you could say like, hey, here's the word potato, it has 100 characters, and then you trust the user that they write, right? Over here, the oversight is that we didn't sort of check whether this is just a number or whether it's just like an arbitrary string of characters. And suddenly, the request that I sent to the database is affected by what I wrote. So I actually can delete all the data if I want to. But again, this is only if the code is not written properly, and nowadays there's a lot of different mechanics to prevent that from happening. But trust me, like 20 years ago or even 15 years ago, this was a very common occurrence, and this would happen all the time. Like people would hack websites just by doing this simple thing. A different type of attack could be like, for instance, here, when I'm trying to log in to a website, right? So I use username Alice and then password, whatever, right? So then the web server might be, okay, database, could you show me a user who matches these details, right? Who has the username Alice and a password equals password, right? And if I find a match, it means like, okay, this is a user. It exists in the database, so it's valid, right? Makes perfect sense. However, again, if it's not coded properly, what I can do is I can do stuff like this. So I can say like, hey, by the way, database, could you show me a user who matches these conditions? They have to be called admin, or the password has to be A, or if A equals A. What does that mean, right? What it means is that A equals A is always true, right? Like A, in every single scenario, A equals A. Like the same thing always equals to the same thing. So what happened here is I affected the condition of the statement. So because A always equals A, everything I just said is true. So it doesn't matter if the password is wrong, because I said I want the username to be admin and the password to be A, or this to be true. So A equal A. Does this make sense? Is it clear? Like, so basically I trick the database into processing something that's always true instead of comparing the password to the real password. And that way I could log in as an admin as well to the website. Again, you don't have to try this on different websites because probably they already secured and they can protect themselves from attacks like that. But just trying to show you how attacks like this could work.
Hi, sorry, it's Tony here. I didn't quite understand the A equals A bit.
Yeah.
Which is true.
Yeah. So in programming, sometimes you have a thing called a if statement, right? So you want to check, for instance, if a piece of data is equal to something, right? So for instance, you could do if user age is higher than 18, larger than 18, then you can allow them to enter the website, right? So what I'm doing here is checking something or asking the computer to check something that I know for a fact is true. So for instance, if I ask the computer, does A equal A? It will say like, yeah, of course, it's equal A. Like, oh, that's a clear thing. If I said like, is A equal B? It might say like, no, because A and B are different letters. So this scenario, what I'm trying to do is ask the server to do something for me and affect the password checking mechanic, right? So if I were to just check if password is equal A, then if it's not A, that's going to be false. That's going to be like, no, I can't find a user of that password. However, if I add a statement that I know for a fact is true, then it means that it doesn't matter if password is not correct, because I said like, if I'm a user who either has this password or if this statement is true. Does that make sense?
Yes, thank you for explaining.
No problem.
Thank you.
So it might sound weird, but actually it's like confusing, like the server will look at this, or like the database will look at this, and they won't question it. They won't be like, are you sure this is right? Are you sure? Like, this looks a bit weird to me. Like, no, they're like, just like, I mean, they're just a silly piece of hardware, you know, silly piece of software. They will just look at it and they're like, okay, if you're telling me to do this, I'll do this. And that's what hacking is about, just sort of, you know, telling machines to do something that they weren't intended to do. Right, okay. So next up, we have a different type of attack, which is slightly different to what we discussed before. It's called a side channel attack. So that is a security exploit that aims to gather information or influence the program execution by measuring twice there, sorry. Measuring indirect effects of the system or its hardware instead of targeting the program or code directly, right? So what it means is instead of trying to actually exploit the code of the program or like the hardware itself, I look or observe things that are happening while the system is running. So you see the image on the right-hand side. I think we can all tell what 4 numbers are used to get into this building, right? Because they've been used so much that the number, my number's actually worn out. So we now know that the password to get into the building has to be one of these 4 characters, right? So obviously whoever designed this system didn't imagine that, yeah, it will be used so much that actually the characters will just wore off from the thing, right? And I'm not hacking the hardware itself. I'm not hacking any software. It's just like I'm observing what's happening, right? So I'm actually listening or taking pictures or whatever, or just like looking, here's how the server works, here's how the system works. And from that, I can make assumptions to actually break into it or affect how it works. So another example of this, I don't know if you ever saw this, have you seen this picture before? So this was a guy who basically trapped an AI-driven car, right? It's a self-driving car, and they've trapped the car by just affecting the environment around it, right? So they didn't touch the car, didn't touch the hardware, didn't touch the software. They just changed the environment around it. So suddenly this car is like, oops, I can't drive here. Oops, I can't drive here. Oops, I can't drive here. And it's basically stuck in this loop within this circle. So this is another example of like, I'm not actually touching the hardware itself or the software. It's like, I understand how it works. And because I understand how it works, I can actually affect something outside of the system for it to be affected. So there are a lot of very interesting attacks that people have employed in the past and are sort of experimenting with. There's even examples of people recording the sound of people typing on keyboards and then being able to distinguish which characters you actually pressed on the keyboard itself because of this different acoustic sort of effect it has. Obviously, you know, you have to know exactly which keyboard it is, and you need to understand what sort of, you know, like what's the behavior of the typing sort of mechanics that the people apply. But again, this is something like you are listening to the environment or you're listening to people using the system and then sort of building assumptions and then, for instance, being able to read someone's password because they typed it in and you either saw it basically through the camera or you just listened to it, someone typing, things like that. So there are a lot of scary things that people can do if they just try to see, okay, what did people not consider here? Like what can I exploit here in this situation? Right. So now I'm going to talk about the most dangerous and powerful attack that a hacker can perform. And this attack is social engineering. So it's psychological manipulation of people into performing actions and divulging confidential information. Social engineering is very often part of major hacking scandals. So you might think like, oh, it's just talking to people. How's it hacking? Trust me, like this is usually a huge part of people breaking into systems. They'll like, you know, phone someone up, say like, oh, hey, by the way, that server's down. Could you just check it for me? I'm Steve from IT and stuff like that. Like people often employ this to install bugs, install sort of worms into systems, Trojans and stuff like that. They often do that. And this is the attack that you as a human being have to worry about the most because you can be part of the hack. Someone can actually phone you up and you suddenly become part of the whole story. Right, so when it comes to social engineering, there's 6 different key principles. There's authority and trust. So if someone contacts you and you know, they claim authority, or you know, it seems to be coming from someone important, or your boss even, or a friend of your boss, you then automatically start trusting them, or you feel like, okay, this is an important person, they must be right. Number 2, intimidation. So when someone contacts you and says like, oh, you're going to be in deep trouble if you don't respond to my email because I'm going to call your boss, that obviously encourages people to comply. Consensus is social proof. So that is, for instance, when, you know, people seem to be, you know, for instance, coming from the same, from a similar phone number, or for instance, coming from being friends on Facebook with someone, you know, and stuff like that. You know, there's some sort of proof that you see, like, oh, okay, well, that means they must be right. Scarcity, which is, for instance, like, hey, this offer is a one-time only offer. If you don't respond to me now, it's over. It's gone. You can't do it anymore. Urgency, where someone says, like, for instance, like, oh, you have to reply to this email now because, you know, like, we only have 15 minutes to do it. And you're like, oh, okay, cool, cool, cool. And then finally, familiarity or liking. So for instance, this means that the person, for instance, has similar interests, or like, you know, is chatting you up and you seem to be going on, you know, like getting along, sorry, and it just feels good. So for instance, here's an example of an email that someone might receive, right? Like, hi, are you in the office? I need you to find out for me. I need you to find out for me if we still have time to pay for an invoice today. So it has urgency, authority, and scarcity, right? Because it seems urgent. So when you see an email like that, you actually might not even check who is it from. You just feel like, oh shit, something's really, really important happening. I have to respond. I have to reply. But you have to be careful. They might ask for you to do something that you weren't intended to do. Next, for instance, phishing, very common thing. You may have heard about phishing with a PH. You see an email and it says like, dear network user, your password will expire soon. Click on this link to reset your password. So that again is urgency, intimidation, and familiarity. So urgency, it seems urgent. You have only 24 hours to comply. Intimidation, you're going to lose access to your university account. How are you going to study? How are you going to apply for grades? Like, nope, it's really, really, you know, you feel intimidated that you have to do it. And in familiarity, obviously, it's just the fact that it's a university and it's your university, and it looks similar. The logo is the same, the signature is the same. So that's how that works. Right, because we're slowly running out of time, so I'm going to try to sort of breeze through the rest of the slides. But I'd like to give you some advice now about what you should do to avoid getting hacked. Right. So don't reuse passwords. It doesn't matter how complicated your password is. If it leaks, scammers will be able to use it across all your sites. So you can tell me like, oh, Magic, but my password is 20 characters long. It doesn't matter. It's so complicated. It's like, no, it doesn't matter. If someone gets access to your password in a leak from a different website, they'll just try that same password on many other websites. It doesn't matter. It's like your password is complicated. If you reuse the same password across different sites, it's a problem, because then you have to rely on every single of those websites to never have a leak, never have a hacker access them. Because once someone has that password from one of the websites, they'll just simply use it on all the other websites and hack into your accounts. So always use a different password. And what you can do is you can use a password manager if necessary. So Bitwarden is a good one. It's free, it's open source. I recommend it. Also, go to haveibeenpwned.com, pound. This website, go to that website. If you enter your email address, you can actually, it's scary, but they will tell you if your email address and password were part of a leak. So try that. And if it says that it has been part of a leak and you haven't changed your password on that website for a while, please do, because it's quite important. Right, next piece of advice, don't get cornered. So always check who the email or text is from. It is very unlikely that someone on the phone will be asking for your password, your credit card number, unless you're actually buying something, other very sensitive pieces of information. And never, ever install anything that the person on the phone is telling you to. Like, never, because they might say like, oh, your computer seems to be not working. Can you go to this link and install this piece of software for us? And it's like, no, usually it's scammers asking you to install a virus or a Trojan to control your computer. So please remember that. And don't be afraid of asking like clarifying questions when someone calls you. Always check who it is. And if you work for like a good company, especially like if it's like a sort of office type of work, they should have a security policy like this in place. And they should make you feel comfortable asking all these questions and stalling if you have to, just to avoid a hack and just to avoid of leaking of information. And then finally, this is the most boring one, install updates. So old software can have security holes. You can try using auto update. I know it's time consuming, but it's always good to install updates and have the most up-to-date software running on your machine. Right, so I promise I'm going to speak about this as well, which is the hacker versus cracker controversy. So actually what I'm going to say is hacking is good. Like, you can learn, improve things. When it turns into cracking, however, that's a different story. So the difference that some people try to sort of make between hacking and cracking is that hacking, they see it as basically taking something apart, changing how it works, putting it back again, changing a piece of software, and then seeing like, oh, cool, this is, you know, I managed to do this, I managed to achieve this. For instance, here's an example, someone hacked a Tamagotchi and made it display different things on it, you know. A cool website to check out is hackaday.com. They talk about a lot of these different hacks. Here's some other examples. For instance, top left, someone managed to play a game on a pregnancy test. So they managed to install Doom, the game, on a pregnancy test and play on that little screen. It's a hack. Someone managed to hack a road sign. I mean, this is probably illegal, but you shouldn't be doing that. But managed to like see how it works and managed to display some sort of text on it. Or the guy below, it's a YouTube channel called Look Ma No Computer. He managed to hack loads of different Furbies to create a synthesizer out of them. So he's playing the keys and the Furbies are actually like playing sounds and stuff like that. So there's a lot of cool things that hackers can do. Like they literally just like grab something, see how it's done, and then just make it work in a way that was, you know, not intended to. But like I said, cracking is, you know, when actually such information and such sort of skill is used for malicious purposes. So to sum up, hacking often exploits mistakes and oversights. That will be a programming mistake, but actually also it could be a mistake in your judgment. So if you get a phone call, for instance, you know, and you make a mistake and you misjudge someone, or you think that they are a fellow employee, but they're not, you know, that's what hacking is mostly about, exploiting those mistakes. So malicious hackers can not only manipulate software or hardware, but also people. So this is what I was talking about. And this is how you can be part of a hack. And that's why I recommend you to always stay vigilant. Stay vigilant, manage your passwords well, install updates. And then finally, the sort of topic that I sort of briefly raised now, you shouldn't be discouraged from hacking. You should be creative. You should experiment with software and hardware. You should try to reverse engineer things. You should be bold. You should learn how things work. It's when you use that knowledge for malicious purposes, that's when it's a problem. But everyone should be encouraged to hack. Everyone should be encouraged to see how things are made, what makes things tick, how things were made. That's how you can improve things. That's how you can learn how to make your own thing. And that's why I encourage you to all be hackers in the good way. I think that's it, actually. I think we got around 8 minutes for questions. So I was trying to speed up towards the end. If you do have any questions, please let me know. But thank you so much for listening. I hope this was interesting for you. And I can try sharing those slides with you as well, if you're interested, after this workshop, so that you can grab any of the links that I've mentioned and things like that. But thank you very much. And yeah, if any questions, let me know. We can try to answer them quickly now. Thank you.
Yeah, we got a few minutes. Has anyone got any questions?
Yes, hi, it's Tony. Sorry, I don't have my camera on. Yeah, I've got probably too many questions, so I'll only do a couple now, and if I can have some time at another day, I'd be really grateful. Now, can you tell me, how can phones be hacked, please? In terms of my son, sometimes he gets phone calls from numbers that are very similar to his. When he answers, he tries not to speak. But the times he's spoken, then the person hangs up straight away. But how can they, and what are the objectives? What are they trying to achieve when they do that? And how do they make the telephone number that they call from look very similar to my son's number?
That's a great question. So I think a few things have happened in the past, and actually quite recently as well. Unfortunately, there's been a large Facebook data leak recently, and that caused people's information and phone numbers to be leaked into the wild. So what that means, actually, it gives a very powerful tool to scammers, because they not only know your phone number, but they actually know your name as well. So if they call you or if they text you, they can use your real name, and it all sounds legit, right? Or be like, oh. So a lot of times, those scammers grab phone numbers from those leaks, and they might have some sort of additional information about the caller, and then be able to basically contact them. There's one other thing as well, which is some phone services allow you to basically have a label attached to your phone number. So when you contact someone, you see the text came from a string, like a piece of text, like, so it could be saying, like, here's a text message from PayPal and stuff like that. So obviously there's a lot of security things in place before phone providers actually allow that to happen, and you have to, you know, go through like a verification process. But certain hackers manage to get that in place anyway. Finally, one way of doing that as well is when it happens on many different types of phones, but when viruses go onto a phone. And one of the ways a virus can get on a phone is, unfortunately, when people try to install software that they weren't supposed to install, in a sense that, for instance, someone sees like, oh, this game is £5, but this website offers it for free. All I have to do is just disable warnings and install that package on my phone. A lot of times, if it's free, there's always a reason why it's free, and usually it's because there's a Trojan attached to it. And when that happens, many different things can happen with your phone. What can happen as well is, for instance, the Trojan itself can go through your phone book and then call even, or make phone calls from your phone to those people. So, there's always a way of doing that. So what I would say is, a piece of advice is to discourage, especially children, because you know, obviously they might have an allowance, but sometimes they want to spend so much money on games on the phone, they might look for free ways of installing games, and those are quite dodgy sometimes. So please be careful about that. Before you ask your second question, I think Billy has a question as well. So I'm just going to go to Billy and then back.
Yes, sure. Thank you very much for answering that one. That's great. Thank you.
There's what's it? I've had those phone numbers. I've had those phone calls, both on my mobile and on my landline. One system that crops up is that it's possible that people are spoofing the phone number. So they're using the phone number that you see is displayed is not the phone number that the phone call is actually coming from, because they're doing it via secondary, they're using some method of obfuscating the original phone number and presenting you with a phone number that's potentially acceptable. One of the problems is that if you, for example, when they start speaking, or when you start speaking and the phone immediately hangs up, what happens is they now know that that's an active number. That sets you up as a target for future attacks. Secondly, if you try and call back, you think you're calling back as a standard phone number, but what you're actually doing, you're being redirected to a premium rate line, and all of a sudden your phone credit just disappears. There's That's okay. Those are one examples. I put it in the chat. I'll say it again. One method of social engineering that can crop up is that if anyone calls you and asks you for your phone number, asks for your contact details or answers to security questions, refuse to answer them. No company that is reputable will do that. They will say, please call our standard number on our website. And you should find, whenever you're set up, whenever you're doing something that's going to cost you money, or when you're dealing with your bank or other stuff, make sure that you've got the number that they provide. Sorry, this is, I had ID theft back in about 21 years back. So this was actually something that, an expensive lesson for me to learn. But basically make sure that when you call them back, you are directly calling them. Don't ever answer security questions over when someone calls you.
Yeah, no, those are very, very good points. And I think, usually if you do get a phone call and someone says like, oh, but we need to verify. I mean, first of all, it's weird that they know your phone number and they're calling you and then they're trying to make you prove that you are yourself. Like, it's a bit strange, isn't it? But normally, if they even do that, you should just ask them like, okay, can I call you back? Where can I find a number on the website that I can call so that I know it's an official number, and then basically confirm that? Because very occasionally they might actually do that and be like, okay, but I need to, get your details. Always ask and say, okay, can I go to your, say NatWest is calling you, can I go to natwest.com and find a number that I can call so I can go through this process? Just so you know it's official and it's not a scammer. So I'm sorry, Billy, you wanted to add something as well.
Yeah, always ask for a name, a job title, and make sure that you've got the name of the company that they're pretending to be. And that way you've at least got raw data. What's it? If they don't start answering, I've found that more often when someone's talking like that, as soon as you start asking those questions, they immediately hang up. That's the point when you know it was a scammer.
Yeah. Sorry, so we're literally on time. So I think unless Tony, was it? Do you have a very urgent question for Maciek? Otherwise, if you want to email him, maybe is that something?
I can stay for another 3-5 minutes if just to answer those questions. But anyone who needs to go can obviously go. But I can stay for another 5 minutes and then just answer those final questions if that helps.
Yeah.
Thank you. That would be great. Thank you.
Sorry, Billy, you raised your hand again.
Oh,
You go ahead, Tony. You can answer. But anyone else who feels the need to go, please do. And I'll upload this on the YouTube channel anyways. And also we'll have more of these workshops. So please keep an eye on our meetup group.
And once again, thank you for joining and listening. I hope you found this interesting.
Yeah, exactly. Thank you, everyone. Tony, what was your question?
Yes. Can I just say thank you before I actually forget? Because thank you to you both for organising and for giving it, because this is so much needed. And I've been trying to find information out. I've tried, but no one's explained it as well as you have. So thank you. Now, one of the, I've got so many. So 5 minutes isn't going to do it, but I'm happy if I can email you or speak to you at some other time at your convenience. But I had an iPad that was hacked. I remember getting, because I'm not very good with technology, and what had happened was I decided I was going to decline cookies from, I think it was Google or, but anyway, one night I was about to use it, my iPad, and everything kind of disappeared, literally. I couldn't get into it. I couldn't turn it off. I couldn't turn it on in any shape or form. And what had happened was it left me just a few links. All my bookmarks had disappeared, all the reading list, everything just disappeared. But it left me, I think it was 3 or 4, what do you call it, links I could click on. One was best birthday wishes. One was apple.com. I can't remember what the other two are. I've got screenshots of them somewhere. But what had happened was I had to click something before I could do anything. That's what I thought. So I clicked on the apple.com one first. It didn't do much, but then when I looked very, very closely, on the O of the com was a little accent on it, which I then believed it wasn't an Apple link. And then the best birthday wishes, it just kind of did something to the iPad for a very long time, couldn't work out what it was doing. And then before my very eyes, kind of maybe at some stage, it looks like someone was mocking up Google. So it started with a small rectangular box, then you could see it getting bigger, and then you saw the letters of Google appearing, all sorts. But can you tell me what could have happened there? When I spoke to Apple, all they could really tell me in a nutshell was my iPad was vintage. They no longer support it. They suggest to buy another one. But they didn't want to acknowledge in any shape or form that I had been hacked, although I had no information, everything been wiped, and I had these links, including the apple.com with the accent on. Can you explain what could have happened? I mean, I've now got a new iPad, so I haven't got the problem, but it's something that really niggles me still, and I don't feel I can rest until I have an answer. Hope you understood everything I said. Sorry.
No, I absolutely did. Yeah. No, I think I partially agree with the Apple staff, Apple geniuses, I think we call them. If it was an old iPad, a lot of the old iPads, especially when they weren't updated to the latest piece of software, they actually were quite vulnerable. There were a lot of exploits that existed. In fact, for some older models of iPads and iPhones, you literally visit a website and the website would take control of your device, just because there were a few exploits in WebKit and Apple's implementation of the browser where you visit websites. and that allowed, for instance, people to what's the phrase? I forgot now. Jailbreak the phone, which means that they were actually able to pass the security measures of their phone and then install custom software on it. So this was used actually by a lot of people for their own gain, as in on their own devices, because they wanted to install like bootleg apps or like new games and stuff like that. However, hackers also used it for malicious purposes. So what could have happened is you visited their website, which triggered that exploit, managed to exploit that bug that was in the code, and then basically installed a few things on your iPad, rebooted it, and then it launched. That's one theory, I think. I think Billy has also something to say.
Okay, minor side note, but important. Always have some sort of credit monitoring set up. Just as basically, if you have a credit monitoring set up, you can start and you get shouts from them saying, "Hey, there's something trying to do this. Someone's trying to do this." That's one point where you can help reduce the amount of what's the word, overall consequences from ID theft or from other or from any forms of social engineering. B, make sure you have your when you have a mobile phone, make sure you've got monitoring set up so that they have to call another number to make any changes to your account. Yes, it's going to be inconvenient, but on the other hand, it stops them. So it stops anyone socially engineering the people who are working on the phone, phone companies, the mobile phone companies, and it stops them. What's it? Trying to, there's one side channel attack where you can finding a sort of harried or flustered customer support agent and saying, "Hey, my phone's been stolen. I need to get it rechanged. I need to get a new thing." And if they make the change without actually calling the other number, then you're it's potentially it's a way of getting around the two-factor authentication that's used as a form of financial protection. That was other.
Yeah.
Sorry, those were just those were relatively important sites.
Thank you, Billy.
Oh,
thank you. Well, I won't take any more time by asking any more questions, Maciek, but if it's possible that I can maybe email you at some stage, I don't know, or or will you be running another session like these where I can tackle a few more questions if no one else asks?
Yeah, I think because I think Maddie's managing the event itself, so she might have your details or be able to contact you via the website, so we can maybe forward it there. I think I think it's also possible to message people on Meetup, so you could probably try that. But yeah, I think something that Billy mentioned is, and I forgot I'd actually mentioned, which is a good piece of advice, is to use also two-factor authentication, because that's a way to protect yourself. Because even if your password gets leaked, you have to then have another factor of authentication involved in the process, right? Which could be a phone number, it could be a device, like you can have a little thing that you have to stick into your computer and press a button on it, for instance, and different ways of doing that, and it's just it means that either requires physical presence or physical ownership of a device, but also knowledge of the password, and that's why it's called two-factor authentication.
Thank you so much. I won't take any more of your time. I really appreciate it.
And I also just wanted to say really quickly, because I know we're over time now, but your question about phones is actually a very good one, because I guess one of the origins of hacking is something called phreaking, which was a lot of people in the past would just experiment with phone lines, and they would like make phone calls for free or pretend to be someone else, because they were just abusing the way the phone networks used to be run in the past, for instance, right? There's still a lot of things possible nowadays to do, but like people would like trade like these manuals, phone manuals about like how to sort of get into different networks and stuff like that, or like how to if you had a public phone, they would be able to like manipulate it and do things with it and stuff like that. So that's the phreakers, and that's where a lot of people see like the origins of hacking, or one of the earliest hacking is like phreakers who were just felt cool that they can like do something that wasn't intended to happen, kind of thing. So
thank you so much, Maciek.
No problem.
Right, Maddie, I'm going to, I can see you rounded up now. So thank you very much.
I'll give Maddie the power back.
Yeah, just
yes,
get in
please.
touch on Meetup, and then we'll organize a bit more so we can have more questions.
Thank you so much.
No, thank you, everyone. I think Magic will probably do another one of these soon. It's quite good. And actually, like you said, there is not a lot of information available just to be able to access like this. I think it's quite quite nice workshop to have. But yeah,
thank you so much. And I'm interested, I will contact you separately about the space that you have there at Islington. Yes. So thank you. And Billy, thank you. You offered a lot of useful information. So thank you very much. I might very well be in touch with you as well through Meetup.
I'm always happy to help. It's
okay.
It was expensive. It was an expensive learning experience for myself, so I'm happy to share
fantastic
some of the routes that I use.
Thank you. Well, I'm going to say goodbye now because I know we've run over by 10 minutes. Thank you all very much.
Bye, everyone.
Bye, Ben.
Bye.
Thank you, everyone.
Bye.
Bye, Billy. Bye-bye.
Bye.
Cool.